Right, here we go. We did this last year. Maybe you just don't remember. Okay, so find where increasing and decreasing. What tells us where things are increasing and decreasing? Well, that's the first derivative. So let's find the first derivative, which it looks like you did well. So the first derivative, 3x squared plus 6x minus 9. And possible places where it could change from increasing to decreasing are you're finding where the first derivative equals 0, and it looks like you did this well as well. If I factor out a 3, then I can easily factor it. So it's x plus 3, x minus 1. And I put it on a sign chart where this equals 0. So I'm going to put negative 3 and 1. And then you're just testing by plugging in values in each interval where it's positive or negative. So if I plug in something like 2 into this product here, that would be positive. And then if I plug in something like 0, I've got negative. And if I plug in something like negative 3, something less than negative 3, like negative 4, I'm going to be back to positive. Okay, so it is changed. So what does this all mean? Well, it means the graph is increasing from negative infinity to negative 3. Then it's going to be decreasing and then increasing. Now, I want to see, I'm just going to look at your work for a second. Okay, yeah, so this is what I do too. So sometimes it's teacher preference, like what they do in terms of increasing and decreasing, whether they use brackets or parentheses, but this teacher seems to, like I do, use parentheses. What I mean by that is, so in part A, it's increasing on the interval negative infinity until I get to negative 3. Oh, I think in your answer, I'm looking at your answer right now, I think you forgot to put the negative with the 3. So maybe change that. And it's also increasing on 1 to infinity. So I tend to use semicolon, but it looks like with domains I use union, but it looks like based on what you wrote, maybe your teacher uses unions, which is fine. So it's increasing on that interval. So that's where this first derivative was positive. Where it decreases the function, meaning from left to right, the function would go down. That would be on where the first derivative is negative. So it looks like negative 3 to 1. Okay, so local extrema occur where it's changing from increasing to decreasing. So if the graph is increasing and then decreasing at negative 3, that means negative 3 is going to be a local max. And we'll find the y value in a second. And then before negative 1, it was decreasing, but then it changes to increasing. So 1 would be a local min. And to find the y values, you're plugging it into the original function. Oof, all right, so maybe I don't have my calculator handy, so let me do this. Try to plug in negative 3. So negative 27 plus 27. Okay, that's actually nice. Plus 27 plus 100. So that should be 127. I'm going to look at my thing to see if that's what you got. Yes. Okay. So now when I plug in 1 to the original function, because remember the points are on the original function. When I plug in 1, I get 1 plus 3 minus 9 plus 100. So that's going to be 104 minus 9. So that should be 95, which is also what you got. Okay, so those are 2 points on the graph, which are helpful. All right, let's go on to the next. To find intervals of concave up and down, this is part B. You need, part C, sorry. You need to find the second derivative. So the second derivative of this function is equal to, let's look at the first derivative and take the derivative of that. So 6x plus 6. I swear to God, I did this exact problem with you guys last year. They probably use the same type of textbook that they get problems from. Okay, so again, so you set it equal to 0 to find possible inflection points. And inflection points are where it could change concavity. And it looks like there's an inflection, like if I factor out a 6, I've got x plus 1. So there's an inflection point at -1. And to the left of -1, if I put in something like -2, I'm going to be negative. But then to the right is positive. So this means we're going to be concave down. And then to the right of -1, we're concave up. Okay, so it's asking first, so part C is asking for intervals of concavity. So we're going to write concave up from negative infinity, oh, not negative infinity, I'm doing concave down. So it's concave up where the second derivative is positive. So we're going to say -1 to infinity. So that means it's, think of it as like smiley. And then concave down, I think of it as a frown. So that's -infinity to -1. So that would look like that. Okay, so since it's changing concavity across -1, that answers our part D. There's an inflection point at -1 where it's changing concavity. And to find the y value of that inflection point, I'm going to plug it back in. So it'll be into the original function. So -1 plus 3 plus 9 plus 100. Okay, so we're going to be, so let's quickly do this. So 111. Yeah, 111. Okay, so now we're going to sketch this graph using all these. So we've got some nice points so that we can just plot on the graph. And again, this is just kind of a rough sketch of things. All right, so it looks, so we've got, so points where things are happening, meaning like increasing, decreasing is changing, local max, local min, and the inflection point are, so it looks like the x is being -3, we've got 1, and we got -1. So let's do the leftmost point. Let's plot the local max, which is -3, and then up high at 127. This is going to be perfect scale. So that would be a max. So I'm just plotting the points, and then we'll talk about what kind of it looks like. The local min is at 195. So the y value is less than 127. So I'm just going to write 195. This point was -3, 127. And then the inflection point where it changes concavity is kind of in between the two. So it's at -1, 111. So let's just write that. So that's -1, 111. Okay, so to the left of -3, I know going back to my analysis that it's increasing. And it's, and then and it also, not only is it increasing, it's also, which makes sense given there's a max here, it's concave down. Because remember, it's concave down until I get to -1. So it should look like that. And then after -1, it changes to concave up, and it's also increasing. So, and we know that 195 is our max, or it's not our max, 195 is our min. So it looks like that. And after you do a bunch of these, you get into the hang of it. You know a max has to look something like this, and you know a min has to look something like that for a smooth, continuous curve. So that's super helpful when you know where the max and min is. And inflection points are just where it's changing from concave down to concave up. So hopefully that is helpful.